we are going to starting with the orthographic projections. So first of all, let us understood about the learning objectives of this unit. The first is study of concepts of orthographic projections. Then to understand theory of sectional views, developing method of reading pictorial views, then developing method of drawing 2D views, and guidelines for evaluation and marking scheme that we are going to observing under this unit. So first of all, let us see about the types of drawings. So the first is natural drawing. That means whatever the landscape and scenery comes or the photography that uh, the map drawings, botanical drawings, plants, flowers, etc. Then zoological drawings, creatures, animals, etc. Portraits, human faces, expressions will come under that type, and engineering drawing. Actually, engineering drawing having two main types. First is orthographic projections and another is
Ma'am, screen is not visible.
I hope the shared screen is visible with all of you. Right?
Ma'am, now it's not visible.
I just refresh the screen. Okay. Can you able to hear my voice?
Yes, ma'am.
Okay. So,
Yes, ma'am.
basically, drawing has two types. Engineering drawing has two types. First one is orthographic projection and another is isometric perspective projections. Okay, so orthographic projections basically the 2D projections, and isometric projections as well as perspective projections comes under the 3D projections. So what is this 2D and what is the 3D? So 2D means two-dimensional and 3D means three-dimensional. So here I'm again going to sharing the screen because many of the students saying like they are unable to observe the screen. Now I hope the screen is visible. So here, as I said, 2D drawings and 3D drawings, right? In 2D drawings, there will be only two dimensions of any object. And in that drawing, or we can say like object is represented by its two dimensions only. Such a type of drawings basically used for production purposes. And 3D drawings are basically used for understanding the features of the object. Okay, and 3D drawing means it has all three dimensions. Okay, so as shown over here, now I hope the screen is visible to all of you. So according to first angle method of projection, sequence of observer, object and plane is the first observer comes, then object comes, and then plane comes. As shown here in middle diagram, so observer will be here, object will be in between observer and plane, and in this case, whatever the projections goes directly on the vertical plane, that view is called as front view. And basically, in actual position, the horizontal plane is actually horizontally placed. So as shown here in left side diagram, horizontal plane is shown here by light blue color, and it gets turned while plotting it on paper. And the intersection point of vertical plane and horizontal plane is called as reference point. So now again I wanted to show you it instead of this by making a drawing over here. So see here, all of you. So what I said initially, the vertical plane, suppose this is rectangular plane. Okay, sorry, this is rectangular plane which is placed vertically. Okay. Which is placed vertically, and another plane which is placed horizontally. After its turning, we are getting it as horizontal plane. And as I said, that is, after turning it, we are getting as a horizontal plane. Okay, after turning it towards left side, from right to left. Okay, and the intersection point of those two planes we are considering as a reference point or reference line. Okay, so here this reference line, above this there is a vertical plane, remember, and below this there is a horizontal plane according to first angle method of projection. If I place this vertical plane like this and this horizontal plane suppose like this, I'm just making it by another color. So see here, suppose this is our VP, which is represented by a vertical line, and this is our HP, right? So this one is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, those are the, sorry, this one is the third, and sorry, by mistake I made this. So this one is the third quadrant, and this one is the fourth quadrant. Okay, and always remember that this horizontal plane turns in clockwise direction. Okay, always remember, horizontal plane always turns, but vertical plane remains same as it is. Okay. So here, I hope the screen is visible to all of you. Yes?
Yes.
Yes, ma'am.
Okay, thank you. So, see, what I said, that is this horizontal plane always turns in clockwise direction and we are keeping vertical plane as it is. Okay, so and we are now learning about this first angle method of projection, in which what I said, that is the object plane, then object, and then observer comes. Okay, the sequence is like this: observer, object, and then plane comes. Means whatever the projections goes on this vertical plane are the called as front view of the object. Okay, and when we are observing this object, just wait, I'm just going to erasing those things so that you can understood very well. So now I'm using another color so that you can understand. Suppose this is our vertical plane. Okay, this is our object. Okay, any shape it has, and suppose we are considering here our observer. Okay, and he looks from this direction to this object, and whatever the projections goes on this plane, this is vertical plane, whatever the projections goes on this vertical plane, that is called as front view of an object. Okay, first of all, plane. What is plane? As I said earlier also, plane क्या होता है? Suppose we take a paper, okay, in our hand, A4 size paper. How many dimensions it has? It has only 2 dimensions. What are those two? Its length and width, right? And that paper thickness is negligible or equivalent to line thickness, right? That is called as plane. And if we place that paper vertically, what we observe? Perpendicular to our eye line, what we observe? We observe a single line, right? And if we turn that paper towards us, then we get its actual length and width, right? Or we can say its length and height, right? If we place it horizontally. Okay, so same way here, this is vertical plane, and if we place that paper horizontally, this will be its horizontal plane, as shown here in quadrant image. Okay, now, so what I wanted to explain you, that is this vertical plane, after turning it towards us, we are getting a rectangular plane, right, on which our object front view will be there. Okay, whatever it is. Okay, and when we turn this horizontal plane, okay, and what I said, this is vertical plane on which we are getting front view, right? And this is horizontal plane. Here, this green color, this is horizontal plane, which turns like this in clockwise direction always. Now, after turning it also, we are getting a single line, right? On which, after turning it towards us, will seem like vertical plane, we are getting horizontal plane like this, right? ये समझ में आ रहा है सबको? All of you getting this concept? First of all, what is vertical plane? What is horizontal plane? Yes, समझ में आ रहा है सबको? Yes. Okay.
Yes, ma'am.
Thank you so much. Okay. So what I said, on vertical plane, we are getting front view of an object, and our object is placed over here while observing it in front direction. We are getting its front view on vertical plane, and when we observe this from top side, right? Top side means ये direction रहेगा, right? As I shown over here by orange color arrow, right? टॉप साइड से देख रहे हैं, इसका प्रोजेक्शंस कौन से प्लेन पे जाएगा? टॉप साइड से देख रहे हैं इस ऑब्जेक्ट को ब्लू कलर के, तो इसके प्रोजेक्शंस कौन से प्लेन पे जाएंगे? प्रोजेक्शंस कौन से प्लेन पे जाएंगे?
Horizontal.
यस, करेक्ट, हॉरिजॉन्टल प्लेन। और ये व्यू कौन सा रहा? टॉप साइड से देख रहे हैं मतलब टॉप व्यू आएगा, राइट? Means on horizontal plane we are getting top view of an object, and after marking its projections, right, like this on this horizontal plane, right, we are turning this horizontal plane in clockwise direction, and both the vertical and horizontal plane towards us, right? And after that we are getting here its front view and top view, as well as the intersection of those two planes. It's called as a reference line. Okay, getting my point? Yes, this is our reference line, remember. Okay, now again, I'm going to explaining you about this first angle method of projection. Okay, so now come to the, now is this is clear to all of you? Above this reference line, which plane is there? Vertical plane. Below this reference line, the plane will be horizontal plane, right? According to first angle method of projection. Okay, and above this reference line, according to first angle method of projection, object's front view will be there, and below the reference line, its top view will be there. Okay, now so as I explain you, this is vertical plane, horizontal plane. This is VP and this is HP, which we'll going to turning in clockwise direction. I'm just going to using this another color for rotation indication, so that you will understood. Now This is our HP. our HP. हॉरिजॉन्टल प्लेन, ये क्या है हमारा? हॉरिजॉन्टल लाइन मींस हॉरिजॉन्टल प्लेन. क्वाड्रेंट्स हम कैसे डिफाइन करेंगे? फर्स्ट क्वाड्रेंट, सेकंड क्वाड्रेंट, थर्ड क्वाड्रेंट एंड फोर्थ क्वाड्रेंट. तो अभी मैं आप लोगों को डिफरेंस बिटवीन फर्स्ट एंगल मेथड ऑफ प्रोजेक्शन एंड थर्ड एंगल मेथड ऑफ प्रोजेक्शन बताने वाली हूँ. तो अकॉर्डिंग टू, और हम सिर्फ ये फर्स्ट एंगल मेथड ऑफ प्रोजेक्शन यूज करने वाले हैं, रिमेंबर. So don't go for third angle method of projection. So according to first angle method of projection, second angle method of projection and fourth angle method of projection will not going to use for projection purpose. Okay. So why those two methods are not used? So here you can understood by sorry guys. Let's come to the point. What I say, that is second and fourth angle method of projection is not used because, see here, always horizontal plane turns in clockwise direction, right? And after that we turn it towards us, okay, for clearly understanding of the views. But if the object is placed in second quadrant, its front view goes on vertical plane, top view goes on horizontal plane, right? But this horizontal plane gets overlapped with vertical plane. So both the views will get overlapped and we can't understood about its views. That's why the second angle method of projection is not used for actual projection method. Similarly, the fourth angle method of projection case happens. The horizontal plane gets overlapped with this vertical plane. Right. So when it overlaps with vertical plane, it's both the views will get overlapped with each other and be unable to understood its view. Now come to this third angle method of projection. Okay. So in third angle method of projection, actual planes are like this. This is our horizontal plane. V is going to turning in clockwise direction, and this is our vertical plane. Now here is object. In third angle method of projection, remember, always the sequence is observer, then plane. Note it down, all of you, please, the sequence at least. And then object comes. So according to this, object is here, right, in third quadrant, and if its projections goes, its top view projections will goes on which plane? Its top view projections goes on which plane? As I shown over here, its top view projections goes on which plane? This is
Horizontal.
Yes, horizontal plane, right? And its front view projections, suppose in this direction from left to right, its projections goes on vertical plane, right? But our this horizontal plane going to turning in clockwise direction, right? Suppose this is our horizontal plane and this is our vertical plane, and this is the intersection point of both the planes. After turning it towards us, we are getting as a rectangular plane having a with a reference line, right? So according to third angle method of projection, the horizontal plane is below or above the reference line. Yes. According to this third angle method of projection, according to this left side corner image, our horizontal plane is above or below the reference line.
Below.
Below.
If it turns clockwise, how it comes below? See, now we are going to learning about this third angle method of projection. See here, as I shown over here by green color, right? And even also I shown over here. This is our third quadrant. Which one? Now I'm going to changing its color. This is our third quadrant. Remember, ये पार्ट मैंने कहाँ से उठाया? ये जो मैंने प्लस सिंबल वाला इमेज दिखाया था आपको, यहाँ से। ये जो मैंने आपको प्लस सिंबल वाला इमेज दिखाया था, ये क्वाड्रेंट मैंने थर्ड क्वाड्रेंट उठाया, राइट? ये यहाँ पे दिया लेफ्ट साइड कॉर्नर पे, ओके? और मैंने क्या बोला? हॉरिजॉन्टल प्लेन टर्न होता है क्लॉकवाइज डायरेक्शन में, राइट? इंटरसेक्शन पॉइंट ऑफ बोथ द, that is our reference point, reference line, as shown over here by brown color dot. Same thing is here. Intersection point of vertical plane and horizontal plane is our reference point or reference line, right? ये तो समझ में आया सबको? ये समझ में आ रहा है? मैंने क्या किया, ये राइट एंगल वाला जो ग्रीन दिख रहा है, सिर्फ उसका वर्टिकल प्लेन हमने, सॉरी हॉरिजॉन्टल प्लेन हमने टर्न किया इन क्लॉकवाइज डायरेक्शन, गेटिंग? एंड ऐसे हमने एक स्ट्रेट लाइन उसको कन्वर्ट किया स्ट्रेट लाइन में, राइट? ऐसे हमने एक स्ट्रेट लाइन में उसको कन्वर्ट किया, ओके? जैसे कि अभी एरो आया इमेज पे ब्राउन कलर से, तो ये ऐसे हमने उसको कन्वर्ट किया वर्टिकल लाइन में। उसके बाद हमने उसको क्या किया, अपनी तरफ टर्न किया, तो हमें ये रेक्टेंगुलर प्लेन दिखेगा, राइट? तो इसके रेफरेंस पॉइंट के ऊपर कौन सा प्लेन है हमारा एक्चुअल में? HP है, रिमेम्बर। एंड बिलो दिस ये वर्टिकल लाइन एज इट इज रहेगा, रिमेम्बर। वर्टिकल प्लेन टर्न होता है क्या? नहीं, so this will be as it is, and this is our vertical plane, okay? Below the reference line there is a vertical plane, and above the reference line there is a horizontal plane, remember, okay? And after turning it towards us, we are getting like this, okay? And this is according to third angle method of projection. Okay. So please remember only about the first angle method of projection. Okay. In first angle method of projection, front view always come. Is the screen is visible to all of you? Yes. Always come above the XY line. Top view always comes below the XY line on horizontal plane, and its side views comes on profile planes. Profile plane means one more plane attached to get its object side view. Okay. So as here also in this image, this is such a type of view actually called as 3D view of an object, oblique view of an object. Okay. In which its arrow direction indicates its front view direction. If we observe at bottom, left side image indicates the shaded portion indicates whatever the front view shape appear as a front view of this object. Similarly, the middle image indicates its top view as the shaded portion. The same image we have to draw or construct. Okay. And here the right side, in right side view, we are getting only two rectangular view or two rectangles as its side view. Right, whatever the shaded portion here, that will be our right hand side view of the object. Okay. Similarly, see this object is having totally this rectangular in shape. There may be a rectangular block, rectangular slot, whether that is top slot from top end or at from bottom end. Okay, but in this image, or we can say in the next object, here it has a curved surface, right? It has a curved surface. Then also in top view, we are getting it's as a one rectangle. Only in front view we are getting as shown over here as a shaded portion its actual circular view or its top end arc with its actual dimensions. We have to construct its front view by showing its actual diameters of those circles and arcs, and those are visible only from the front end or front side. In top view we are only getting here one rectangle as shaded over here and this flat surface as shaded over here. Okay. And in right side also we are not getting this object is having a curved shape or curved surface. Here simply L shape we are going to constructing as its side view. अब एक पेपर का एक रोल बनाओ. लास्ट टाइम मैंने आपको एक दिखाया था सिलेंडर, तो उसमें क्या था मैंने बोला था जो हमने कंस्ट्रक्शन किया कौन सा कर्व्स में हेलिक्स का. राइट, हेलिक्स ऑन सिलेंडर। उस केस में मैंने आपको एक पेपर रोल करके दिखाया था। इवन ऑल्सो वन wooden cylinder I have shown you, and what I said, that is that having its outermost generators, and those outermost generators, instead of curved surface, we are showing its front view as a rectangle, right? Getting my point? Same way for curved surface of an object, if we are not getting its actual shape in that view, in that case we are just observing its outermost generators. Okay, so the same case I wanted to show you how it comes.
Hello friends, we'll now learn to create orthogonal views of objects. First, let's sort out some conventions. There are two popular projection methods, first angle and third angle, shown with these symbols.
Please take a screenshot of these symbols, which are very important. Please take a screenshot of those symbols and keep with you, because while constructing the sheets, we need to construct it on sheet.
In practice, the first angle method of projection is widely used. So we will use the same. Let's apply it to this interesting object. This L-shaped solid object is lying in the first quadrant. We'll see how to draw its front, top, and side orthogonal views. So, first draw a horizontal reference line XY. Then a rectangle 1, 5, 2, 6, 12, 10, and 11 line is drawn above XY line. The numbers in the parentheses represent the hidden corners. This is the front orthogonal view of the object. Next, draw a line 3, 7, 4, 8 parallel to the line 1, 5, 2, 6 at a height of 8 units. The rectangle 1, 2, 4, 3 is the front view of the horizontal L-shaped stem of the object. Now, let's construct the top view. As we can see, it is a rectangle of dimensions L by W. We extend vertical projectors from 1, 5 and 2, 6 below line XY. Then a line 9, 10 is drawn below and parallel to the reference line XY. Next, draw the lines 9, 3 and 10, 4 equal to the length L and join line 3, 4. This rectangle is the required top view. Now, the object is viewed from the left side. So, we can see the L-shaped image on the auxiliary plane. This view appears adjacent and to the right of front view. First, draw a vertical reference line MN, which intersects the line XY at point B. From point B, a construction line is drawn, inclined at 45 degrees in the fourth quadrant. This line is used for transferring distances across different views. Now, Draw projectors from the corner points of the top view to meet this inclined line at 10 dash, 12 dash and 4 dash. Next, from front view, draw horizontal projectors from points 26, 48 and 1210 parallel to the line XY. From points 10 dash, 12 dash and 4 dash, vertical projectors are drawn upwards to meet these horizontal projectors. Join intersecting points to form the side view. This is the complete set of orthogonal views of this object. Finally, draw the first angle projection symbol at the right bottom corner. My friends, let's now create orthogonal views of this machine bracket as seen in the direction of the arrow. So, draw a horizontal reference line XY. Observe, from front side, the bracket appears to be a rectangular slot of size 100 mm by 70 mm and its thickness is 15 mm each on the each side. Now, on the top of this rectangular slot, there is a hollow cylindrical block of diameter 60 mm which appears as a rectangle of 60 mm by 20 mm. The cylindrical block has inner diameter of 40 mm. There is a through hole of diameter 30 mm. These parts are shown with dotted lines as they are hidden in front view. So this completes the front view of the bracket. Now, to construct the top view, project all details from front view below reference line XY. Draw a vertical center line from the center of the rectangular slot. The top view of the rectangular slot appears as a rectangle of size 100 mm by 80 mm. Here we can clearly see the holes in the center of the rectangle. These holes are drawn taking the common center point on vertical center line. The two holes on the fillets are not visible, so they are projected as dotted lines. This completes the top view of the bracket. So let's draw the side view by projecting the details from front view and top views. Don't forget to give necessary dimensions. So that was simple, wasn't it? Now you know all the necessary techniques and theory behind orthogonal views of objects.